Last week we explored ways to redirect traffic from apps running locally into those running in a cluster, and vice versa. During that discussion, I completely ignored the fact that traffic mirroring is only a part of the story. The second part is about deployments. So today I thought to close the circle and try to find a tool that will do both. I am looking not only for a way to mirror traffic from and to apps running locally, but also to deploy new releases to ephemeral environments like those generated as a result of creating pull requests. In other words, I'm looking for a tool that will do everything related to deployment and networking for all the phases of the development lifecycle until the app is deployed to production. Let's talk about development lifecycle. It starts on a laptop. We are writing code of a new feature, and while doing that, we need to test that code. That means two things. We need to be able to run the app locally, and we need to connect it to baseline apps running somewhere else. Running the whole system locally is madness, and I will not go into details of that part since we already covered that in this video. Once we are finished with a new feature, we create a pull request. I will leave out of this story the part that explains how someone might want to review the pull request, how we should run unit tests, how we should run linters, security scans, and so on and so forth. All that should be done automatically through pipelines, or what you might call CI. What I want to focus on is the deployment part. We want to be able to test both automatically and manually the new feature in the context of the whole system. Without tests, we cannot know whether it behaves as expected and whether the PR should be merged to the mainline and ultimately deployed to production. To test something, especially in the context of the whole system, we need to deploy it somewhere. Now, just as it's madness to deploy the whole system locally, it is insane to deploy the whole system remotely as well. While running the whole system locally poses problems with the resources, your laptop might not be able to handle it. We often do not have such restrictions in the cloud. However, deploying the whole system for each pull request would probably result in bankruptcy. We could have tens or hundreds or even thousands of open PRs, and multiplying the whole system for that number would be insane. So, what we want is to deploy only the bare minimum to test the new feature while relying on the baseline system to provide all the dependencies. And that poses two questions. How do we deploy the bare minimum, and how do we connect it to the baseline system? Typically, we would rely on different tools to answer those questions. Today, however, I want to explore a tool that might provide the answer to both of those questions. The tool is called Signadot, and we are about to see it in action. But before we do, there is something important I have to say. It might look like we are solving the same problem that Telepresence, MirrorD, and other tools are solving, and we are. However, Signadot tries to solve a few others. So, even if you say, I already saw the solutions for this, you will have to stay, because we will solve some new ones a bit later. With that out of the way, let's get started. There are quite a few different cases I want to cover today. The first one is about local development. How do we develop locally while being connected to remote apps for all the dependencies? Now, I already have a production-like cluster up and running, and all the applications are deployed to it. Those are two applications with Pinger depending on SillyDemo. If we send a request to Pinger, it will forward it to SillyDemo, so testing one of those requires the other one to be running. And we can confirm that by sending a request to Pinger and instructing it to ping SillyDemo. The output from Pinger is the message from SillyDemo. Next, I will switch to a separate terminal, go to the directory with Pinger source code, and run the application. And now comes the question. What happens if I send a request to Pinger running locally to ping SillyDemo? It responded with, I have no idea where SillyDemo is. SillyDemo is a backend application running in a production-like cluster. It is not accessible through ingress, and it would be silly to expose it just for me. This is where Signadot local comes into play. Now I can connect to the production-like cluster and I can create the first sandbox by executing Signadot sandbox apply with the path to the configuration file and a few variables, which I will explain later. Sandbox environment is a kind of isolated environment containing only the bare minimum to test the new feature and connect it to the rest of the system. For those of you liking pretty colors, we can see sandboxes from a web UI as well. Now, going back to the terminal, I will repeat almost the same request as before. The only thing I will modify is the address of silly demo. Signadot needs to know in which namespace it is running, so I added it next to the name of the service. That's what I did. This time my local app responded with a message from silly demo running in a remote cluster. Here's what happened. I sent a request to Pinger running locally, which in turn tried to communicate to the service sillydemo.demo on port 8080. Signadot in turn intercepted that request and redirected it to the remote application behind that service. To do that, it changed my etc host file and added network mappings to the cluster itself. Now, if you paid attention, I used a configuration file to help Signadot figure out what I want. So let's take a look at Signadot Pinger local YAML. In the nutshell, I'm telling it which cluster to use through the variable, instructing it to use a specific deployment in that cluster and map it to the application running locally on port 8080. Now, if I would be using Istio, that's all I would need to do. It would use it to configure virtual services to redirect traffic. However, I don't have Istio in this cluster, so I went for the alternative method. To do that, I had to add an annotation to deployment YAML instructing Signadot to inject a sidecar proxy for HTTP requests. And that's all there is to it for the first use case. So let me delete this sandbox by executing Signadot sandbox delete with the same arguments as before. Let me switch from developing the Pinger app to silly demo. To do that, I will stop Pinger from running locally and I will switch to the directory with silly demo source code. And I will run it. Next, I will create a new sandbox with almost the same command. The only difference is that I'm using a different configuration file. And this time the output is slightly different. I got a special URL through which I can access Pinger running remotely. Let's see what I can do with that URL. I'll store it in an environment variable URL so that I do not have to remember it. I'm old. And output the complete address I want to use. Now I can open Pinger running remotely in a browser. We can see from the output that remote Pinger did not forward the request to remote silly demo as it normally does. Instead, the remote app forwarded the request to silly demo running locally. Here's what happened. I sent a request through the special Signadot URL to Pinger running remotely. Pinger in turn forwarded that request to silly demo. However, Signadot intercepted that request and redirected it to silly demo running locally. Let's take a look at the configuration file I used by outputting Signadot silly demo local YAML. This one is similar to the first one, except that this time I'm targeting silly demo instead of Pinger. There's also a new entry, default route group, which tells Signadot that I would like to generate a new endpoint based on Pinger running remotely. So I'm developing silly demo locally and I'm exposing Pinger running remotely. And now comes the interesting part. What should we do once we're finished working locally and would like to test the new feature deployed remotely? Now, before we dive into that one, which is probably the most interesting use case, let me delete the sandbox by executing Signadot sandbox delete. And by the way, I will also stop silly demo from running locally. We do not need local anything anymore. We are now going towards creating pull requests. Imagine that we finished writing code and created a pull request which executed a pipeline that built a new image that we would like to test. Now, I will not go into the details of creating CI pipelines. That would be a subject of a different video. What matters is that I'm faced with two problems when trying to test the new feature. How do I redirect traffic from the application with the new feature to the rest of the applications running in the production-like cluster? And two, how do I know what to deploy? What is the minimum required to run that new feature? Let me start by resending the same request I sent at the very beginning of this video. That was a request to Pinger running in the production-like cluster. It forwarded the request to Silly Demo, also running in the same production-like cluster. Neither of those two apps contain the feature I want to test before merging the PR to the mainline and moving it to production. As you can guess, I will create a new sandbox. The only difference besides using a different configuration file is that I'm using a variable tag to specify the image tag I want to use. That's the image I built as a result of the pipeline that executed when I created the pull request. I got yet another special URL through which I can access Pinger. However, this time that will be Pinger in the sandbox and not the one running in the production-like cluster. To be more precise, sandboxes are, at least in this context, running in the same cluster, so I really wanted to say that it is not the baseline Pinger. Let me store that URL in the environment variable. Now I can test or try it out with, let's say, curl, right? I'm not running real tests this time. Curl CURL should be enough. Now, there is an annoying part here. I have to add Signadot API key header to the request so that Signadot knows that I'm authorized to access the sandbox. The rest is the URL itself. The output is this time different. It comes from Pinger in the sandbox, which forwarded the request to Silly Demo from the baseline. Alternatively, I can output the full address without the Signadot API key and open it in a browser. The result is the same, and since it is coming from the browser, there is no need for the API key since I'm already authenticated with Signadot. We could have done the same from the UI. If you open that specific sandbox, we can see, among other things, the URL we can use to access it. Here's what happened. The baseline contained the Pinger which communicates with Silly Demo. I created a copy of the necessary resources from the Pinger baseline. That saved me from having to deal with Pinger manifests, choose what I need and what I don't, how to reconfigure them to use dependent services from the baseline, and so on and so forth. Further on, I sent a request to the Pinger in the sandbox, which in turn forwarded it to Silly Demo in the baseline. Finally, let's take a look at the configuration file I used by outputting Signadot.Pinger YAML. There are quite a few differences here. To begin with, I specified that I want to create a fork of the deployment called Pinger in the namespace configurable through the variable. Further on, I specified customization by saying that the image should contain the tag specified through the variable. Finally, the default route group is pretty much the same as before. Now, let's take a look at what's running in that namespace. Apart from the baseline resources for Pinger and Silly Demo, there is a new deployment. That's the fork created by Signadot. There is also a new service created automatically by Signadot. You should also notice that Signadot created sidecar containers in baseline Pinger and Silly Demo pods. Those would not be needed if I use Istio, but since I don't have it, Signadot injected them to intercept traffic. Now, let's imagine that we saw that something should be fixed. We changed the code, pushed it to the pull request, and the pipeline executed again, building a new image. To test those changes, all we would have to do is execute the same command, Signadot sandbox apply, but this time with a different tag variable. Now, to be clear, you should be executing commands like that through the same pipeline you're using to build the image and do whatever else you're doing. I'm running everything manually, mostly to have easier time showing what's happening. Anyways, let me refresh the browser and voila! The new tag is running. Now, there are quite a few both good and bad things about Signadot that I want to discuss next. But before I do, let me delete the sandbox. Signadot is special. Some of the problems it tries to solve, like network mirroring, are already solved by other tools like, for example, telepresence. What makes it special is that it combines solutions that already exist with some new ones. Specifically, it enables us to fork resources from the baseline and modify them instead of trying to figure out what to deploy from scratch and how to isolate that from the rest of the system, while still enabling communication between sandboxes and baseline applications. It comes with its own set of challenges though. So let's start with cons. To begin with, Signadot does not respect environment variable kubeconfig, nor it has an argument to specify the path to the kubeconfig file. That's very annoying, since it is often easier to have different kubeconfig files for different clusters instead of switching contexts and making the default kubeconfig a nightmare to manage. Next, Signadot relies heavily on etc hosts file, and that's great. That's absolutely great. What is not great is that it leaves the entries there even after the sandbox is deleted. As a result, your etc hosts file will likely become a mess very, very fast, and you will have to clean it manually, even though the entries scream at you with the comments, "Do not delete me." What else? Signadot is not open source. I do not necessarily have a problem with that, but its competition is open source. So you would be hard pressed between choosing open source tools, which later on you might upgrade to commercial versions, or go with a commercial solution from the start. Now, to be clear, there is a free tier, so you can still try it out. Also, when I said that it is not open source, I meant that the core is not open source. Signadot has a plugin system and plugins are open source. What else? There is no self-hosted version of Signadot, which might cause issue for those not being able or not wanting to use SaaS. Forking resources is limited to deployments, Argo rollouts, and a few plugins. If you need to fork other resources, you will need to write the plugin yourself or wait until someone else does it for you. I feel that forking of any resource should be a core feature and not something that should be done through plugins. I think that Signadot could have made a more flexible config format and let users specify what to fork, a path to fields that should be changed, and how to find services for networking. Speaking of Signadot configuration files, I believe it would be better if they are backed by Kubernetes CRDs and defined as CRs or custom resources instead of client-side only configuration files. If CRs were used, it would work with, let's say, Argo CD and Flux, and it would integrate better with the rest of the ecosystem. Now, there are CRs, Signadot sandboxes, but those are created as a list instead of proper custom resources backed by a proper custom resource definition. If those are usable, if you could use those directly, there is no documentation about it, so I will say, no, you can't. Since Signadot is forking or copying baseline resources from the cluster, it assumes that baseline manifests do not change. If, for example, we do modify the baseline manifests as part of a new feature we are working on, we would need to deploy them as baseline resources and then fork them. That would defy the purpose of forking in the first place. And finally, having to specify which resources to fork or to copy might be tedious. Wouldn't it be better if it would evaluate manifests of the new release and then apply only those that changed? How about that? Now let's go to good things, to pros. To begin with, it solves the problem of sharing dependencies more or less effortlessly. Next, it combines network mirroring and deployment of new releases to pre-production environments into a single tool. And that's awesome. That's absolutely awesome. Finally, documentation is absolutely great. Way too often, relatively new projects have poor documentation, making experience with them frustrating. Signadot's documentation, on the other hand, is exceptionally good. All in all, I think that Signadot is great, but for specific use cases. The idea of forking baseline resources works fairly well for monorepos and or distributed monoliths when it's fairly complicated to distinguish between what's part of the baseline and what's part of the new feature. On the other hand, if you're developing microservices As independently deployable small units, it would make more sense if you just deploy normal manifests. In those cases, Signadot could have developed mutating admission controllers that would do the same thing it is doing now, but without the need to specify what to fork. In that case, I would imagine the need for a few additional annotations, just like the one I specified, to let it know that it should create sidecar containers. Now, I'm not saying that Signadot is not a good solution. As a matter of fact, I like it. I think it has a lot of potential. I do not know of any other similar solution. It solves a few problems, some of them in a very unique way. So, go on, try it out. Thank you for watching. See you in the next one. Cheers.